Okay, so link 1, link 2. Okay, we've seen this. We've used just simple rotation matrices to describe this manipulator. Now we'll use the DH convention on this. So x0, y0, and then this is theta1, this is theta2, and then the link lengths are L1 and L2. Okay, so the question is find the position and orientation of the end effector, right? End effector is the second link, the one which has degree of freedom theta2. So let me just redraw this and essentially copy this, because we will start establishing axes based on the DH algorithm I just talked about. Okay, step 1. Okay, so go to your handout, and if you're I would say you should just listen me do this instead of writing it down, because this will actually get quite it can get slightly more you need to sort of observe what I'm doing and then sort of do it yourself later on when you do homework problems. So just follow me. Just if you want, don't take notes right now. Assign the coordinate frames. So this is a step 1. Okay, so if you go to the handout, there is A, B, and C. Okay, first step says that, and I'm going through the handout which I just sent through Zoom. Okay, so first step is assign Zi along axis of actuation of each link. Okay, so what's the axis of actuation? It's the axis along which this manipulator moves. So here we can see that it's moving along the Z-axis, right? So the Z-axis is going to be like this, and then the Z-axis is this way. So this is a 2-dimensional drawing, but the following questions will be 3-dimensional. So that's the axis. So Z0, C1. Okay. So assign Zi, which I just did. The second step is you need to assign frames. So assign the base frame. So base frame is also the fixed frame, which is O, X0, Y0, Z0, which is already done for you. So you don't have to do much here. Okay, now we'll go to step C, and which is probably the most intricate one. Step C tells you how to assign frames X, XI, YI, ZI for the subsequent links. Okay, now there are 3 things here. There's 1, there's 2, and there's 3 if you see the handout. And it really depends on how these links, the ZIs, are dependent on each other. By the way, I forgot to do something here. I should also assign a frame to the end effector, which I just completely forgot. So let me just assign a frame, which is this way. In fact, the rule says that you need to assign it along, let's say, oh, it's coming towards the end, never mind. This is actually step D. I just jumped ahead of myself. I'll come back to that in a bit. So let's go through step C, which says there are 3 cases, which basically tells me how Zi and Z0 or the adjacent Z's are linked. If Zi minus 1 and Zi are not coplanar means things are not in the same plane. So in this case, this does not apply. Okay, so if you think of this, and this is really hard for me to, I wish I could show it to you in person. It's the axis z0 and z1 are actually parallel to each other, right? Because this z0 is pointing, sticking out of the plane of the paper, and same for z1. So really, the first one doesn't apply. The third one, which is does z0 intersect z1, does not apply. The only one which is true is the second one. This applies, and if that applies, then this tells you, the handout 1 sub C2 tells you that you want to attach x0. So I'm reading it out from here. Uh, in, in case zi minus 1 and zi are parallel, or z0 and z1 are parallel, there are infinitely many perpendiculars between z0 and z1. So I'm just drawing some of the perpendiculars. Choose any of these perpendiculars. So you can choose any line. Okay. There's actually a suggestion. You have to draw, if you draw the perpendicular to be the one which intersects z0, then that will be the simplest one. So in this case, it's saying that choose x1 or to be along the line which actually intersects length z0. So that's why I put x1 here. Okay. And then if you want to find y1, so that's x1, that's z1. Y1 is simply right angles to x1, such that x1, y1, z1 form the right hand rule. Okay. And then so we've done this for links z0 and z1. In fact, there are just two links here, so we don't have to do more, and that's where 1c ends. Finally, we need to go to 1d, and d says how to attach the end effector frame. So end effector is right here. It says that attach zn to the same direction as zn minus 1. So it says attach z2 along z1. That's what it means, right? Zn along zn minus 1. So that's what I did here. And then depending on the relation between zn and zn minus 1, so depending on how z2 is oriented with z1, in which case, in this case, it's actually parallel to z1, just like z1 was parallel to z0. Choose the x-axis to be along one of the perpendiculars. In this case, if you choose it to be perpendicular and intersecting z1, then you're better off. So that's x2. So we have attached the coordinate frames. That ends D. And the next step is to generate the DH table. So what I'm going to do is, I'm out of time, I'm going to stop here. You should have got the handout via chat. I sent it as a file. You can open that. Okay, so what we are going to do essentially today is solve two problems related to manipulator kinematics using DH convention. And as I said, there are three steps. The first step is to assign coordinate frames. Okay, and when I write things down, I'll actually mark 1A, B, C, D, which is basically these steps in the handout. Okay. The second step is to generate this DH table, which is based on the first step, which essentially establishes the axis. The third step is very straightforward. It is basically writing the H matrix from this table, and there's a H for each line of this table. And so we'll write H1 with respect to H0, H2 with respect to H1, and so on. And that helps us to define the transformation from nth frame to frame 0, which is basically saying what is the position of the end effector with respect to the world frame or fixed frame. This H matrix gives me the rotation of the end effector and the distance of the end effector from the base of the robot. And that is what I need in order for the end effector to pick up an object, right? If there's an object in the scene, the robot will pick it up because we know this position with respect to the global reference frame. And that's what we are trying to get through this H matrix, Hn with respect to 0. Okay, so I started off with a very simple problem which we have done in the past, consisting of a two-link manipulator. We used the rotation and translation formulas to solve this problem, and I'm going to redo this problem using DH. So that sort of will give you an intuition about how DH works, and then we'll move on to harder problems. Okay, so here's a two-link manipulator. with link lengths L1, L2, and theta 1, theta 2 are the degrees of freedom. I've already drawn the x0 and y0 axis. The question you can expect is find the position and orientation of the end effector. So the end effector is basically this point. Okay, that's the point where you'll put a gripper, which will then go to pick something, or if you have a pen, you can make it draw different shapes, something we've done in the previous homeworks. So what I'm going to do is I did start it, but I thought I should just redo it all over again. And bear with me, this is actually much easier to explain if you can see me actually do these um, assignments, and you're viewing me as well as the computer. But since there is that modality, it's very difficult for me to show you what I'm doing with my hands, to show you the distances and so on. What I'm going to do is I'm going to try to write down everything, so I'm going to be a little bit slower than usual, but hopefully this will replace me actually showing you how these distances and angles are calculated with my hands, which is really the way to do it. Okay, so bear with me. I'm going to redo this problem again. Follow the steps 1 to 3, and you might want to keep your hand out with you when I do this. So first, let me redraw the manipulator. The only thing I know right now is there's axis x0, y0, and I know the link lengths, and then I've been given these are thetas. Okay, so here we go. Step 1. Okay, so if you have not opened the handout, please open the handout. We are going to follow 2.3, which says the steps. So first step is assign coordinate frames. Okay, what that means is for each link I need to assign x1, y1, x2, y2, and so on. So step A in the handout again. Assign zi, I'm just reading out from the handout. Assign zi along the axis of actuation of each link. Okay, so what does it mean, the axis of actuation? This is basically the joint at which this link one is going to move. So that's the axis of actuation. Here's another one. So if there's a robot with n degrees of freedom, there would be n axis of actuation. So let's assign axis for over here for link 1. So that will be z0. And then for the second one, so z1. Okay, so that completes A. Okay, next let's move on to B. So B says assign the base frame OO, XO, YO, ZO. The Z0 has already been assigned. Assign X0 arbitrary. Assign Y0 based on X0 and Z0. So this is just establishing the base frame. Okay, we've already done this. This has already been done. So we will not spend the time doing this. Okay, we'll see a problem where this is not done and then we'll have to do it. But right now it's already done for you. Okay, let's get to step C, which is the next page. Okay, now this one is probably the most tricky one, which is you need to assign the axis x1, x2, and so on. Okay, so there are 3 things here. If you check, there's one which is the z-axis. So we'll do this for each and every combination. So we look at z0 and z1 and try to see how they are related. And based on that, we will use either 1, 2, and 3, where 1 is the Roman one. Okay. So the first one says that is zi minus 1 and zi are not coplanar. So I can tell you with certainty that almost all the problems in this uh, class are not will involve a case where the things are going to not satisfy number one. Not coplanar means they are not in the same plane. Okay, so this does not satisfy that because they are actually, uh, if you can think, they're actually parallel. If you can imagine this figure in 3 dimension. So 2 is, are they parallel? That is actually true. Z1 and Z0 are parallel to each other. So Z0 and Z1 are parallel. Okay, so if they are parallel, So this is number 2 from the handout. There are infinitely many perpendiculars, right? So this is one perpendicular. You can draw another one like this, and then you can draw more like that, right? So there are infinitely many perpendiculars. So what the suggestion is, try to draw xi, here I equals 1, so that it intersects zi, which is uh, z1. So in this case, what we'll do is we'll try to draw x1 like this, because that intersects z1, and that actually makes our life easy. Okay, so that's just a suggestion. You could choose any other perpendicular. Okay, so that's step 1 with Roman numeral 2. Okay, we don't need to look at 3 because we already found one case which satisfies this. The final step D is we need to attach an end effector frame, right? So we've not attached anything to the end effector. So how do you do that? Well, the suggestion here is choose Zn, where n is the end effector, to be parallel to, same direction as Zn minus 1. So here that's Z1. So let's assign Z2 along the same direction as Z1. And then we use the same logic as C. So once we do this, Z2 is attached. Now we need to assign X2. So it says the handout, this is 1D says, so depending on the relation between Zn and Zn minus 1, so in this case Z2 and Z minus 1, attach frame Xn, so X2. Okay. So how do we find the relation in Z1 and Z2? Well, we'll have to go back to C, because C gives us the relation between Zn and Zn minus 1. Okay, so we need to go through, so to attach X2, we need to go back to 1, C, and then we need to go through case 1, which is, are they not coplanar? That's not true. So we'll rule this out. We go to 2. 2 says that are Z2 and Z1 parallel, which they are. So we'll apply number 2. So number 2 says that there are infinitely many perpendiculars between Z1 and Z2. Choose the perpendicular which intersects Z2. So this is the one. And so we'll draw X2 in this fashion. Okay. And then we are done. Now, something else which I did not do, and you can do it if you want, but really it as though bearing with the solution, is to attach frame y0, y1, and y2. So y0 is already attached. Y1 is going to be essentially, uh, will be essentially use right hand rule to determine y1. So x1 is this way, y1 has to be in the direction I've shown, such that x cross y is z1. So this is right hand rule. Curl your right hand from x1. So the four fingers on your right hand from x1 to y1, and your thumb will give the direction of z1. Similarly, we can show that y2 is in the direction shown. So you can put this if you want, but it's really not, it does not have bearing with the solutions which will develop. Okay. So we've finished step 1. Let's go to step 2, okay, which is generating the DH table. So here we have the table, which is AI, alpha I, TI, theta I. And we really need just 2 lines for this table. We have I equals 1 and I equals 2. So we are going to populate this 8 numbers now, okay? Okay, so how do we populate them? Well, we need to know what AI, alpha I, di, and theta mean. So if you go back to my last lecture, I actually showed you what these distances are, right? It is AI is the distance between Zi and Zi minus 1 along Xi, and then alpha I is the angle between Zi and Zi along Xi. And so I think it's very difficult to parse this information. Uh, it's somehow it's very hard for me to actually look at this information to populate the table. So I'm going to give you some sort of a cheat sheet or a way to actually do this without actually remembering what this words say. Okay, so the trick is, and I found it useful to do it this way. So what I'm going to do is I'm just going to show you put two pictures here, and I think those will help us find these four numbers rather quickly. Okay, let me actually move this on the next page because I want to look at the figure and then fill the tables. Let me just do that first. Okay. Okay, so let's do it for number two, DH table. So I'm going to try to get A1, alpha 1, D1, and theta 1. Okay, and so this is how I remember that four steps. Yes, it should be in the handout. So I draw these two figures, one for um, AI and alpha I. Okay, and I'll tell you what this figure really means. So that's one figure. The other figure I'm going to draw is for this is for AI alpha I, and the other figure I'm going to draw is for DI theta I. Okay. So DI theta. Okay, so what this figure is doing is trying to put that information on that previous page I showed you in two simple figures. Okay, so how do we really interpret this? A AI or A1 is going to be the distance from zi minus 1 to zi along xi, and alpha is going to be the angle between zi minus 1 and zi along axis xi. That's how you interpret this picture. Okay, so let's do this. Okay, I'm going to just replace the xi with x1, and then this with 1 and this with 0, right? Because I is 1. Okay, so now with that, let's try to see how do we write these numbers. So A1 is the distance from Z0 and Z1 along X1. Okay, let's see. The distance from Z0 and Z1, use a different color. Okay, so distance between Z0 and Z1 along X1, along this. Okay, it has to be L1, right? Because Z1 and Z0 are parallel, the distance is L1. Next is alpha I. It's the angle from Z0 and Z1 as measured along X1. So it's the angle between Z0 and Z1 along this axis. Okay, so if you think of this, Z0, if you look at the figure from here, then Z0 is something like this, Z1 is parallel to it, and I'm trying to find, I draw it this way, Z0 is here, Z1 is there, and I'm going to view it this way. So this is X1. Okay, so I need to find the angle between Z0 and Z1 along X1, but you can see that Z0 and Z1 are parallel to each other. So the angle between them as viewed from this side is going to be, well, actually, you need to view it from You always need to view it from this way, my bad, along the positive axis. So it's actually going to be 0 because they are parallel to each other. Okay, so this completes the first two lines. Similarly, let's, okay, so for the second part, we need to replace I with 2, sorry, I with 1. So here we'll have z0, and then we'll have x0, and then this will be x1, and this will be theta 1. Okay, now let's try to get d1 and theta 1. So d1 is the distance from x0 and x1 measured along z0. So distance between x0, which is this, and x1, which is this, along z0, right? Z0 is here. So if you want to find the distance from this line, well, let me put a different color. Let me choose green. This line and this line along the z0 axis, so along this way, then you can see that they actually are intersecting, and so that distance is going to be 0. Okay. Finally, we need to find the angle between x0 and x1 measured along z0. So that's going to be angle between x0 and x1 measured along z0. So that's basically you need to rotate x0 to x1 along z0. So if x0 is this way, x1 is that, z0 is here, then this is the angle which you'll rotate it from. And you can see that's theta 1. So this is going to be theta 1. So that's the first line of the DH table. Okay, so that's how you do it. It's not hard once you start figuring out what these A's and alphas are. And I think my way of doing it is this. If you have a better way, feel free to use it. Okay, so let's now do this for the second link. It's going to be the same step. And for this problem, actually, it turns out that the values are essentially the same with ones replaced with 2. But let's just do it again. Copy. Okay, so that is, let's now change this from 1 to 2. We don't know this yet. So this is 2, 2, 2, and theta 2. And then we'll replace this with 2, 2, 2, and 2. And then here we have 1, 2, 1, and 2. Okay, so let's do this now for the second link. So first, let's do A2. A2 is the distance from, I think I did a mistake here, Z1. Hold on, let me check. So it's Zi minus 1 to Zi. This looks right. This looks right to me. And then x2. Okay, this looks right. So A2 is the distance from Z2 to Z1 along x2. So Z2 to Z1 along x2. So x2 is this axis. So it has to be L2. alpha 2 is the angle between z1 and z2 measured along x2. Okay, but as I said earlier, z1 and z2, if you can imagine, they are actually parallel to each other, so the angle is going to be 0. Okay, next we look at this figure. We have to find the angle between, sorry, distance between x1 and x2 measured along z1. So distance between x1 and x2 measured along z1. So z1 is this way. Since those two axes, x1 and x2, intersect, that distance is going to be 0. And finally, we need to find the angle between x1 and x2 as measured along z1. So you can see that simply theta 2. So that basically is the second line of the DH. So now what I'm going to do is I'm going to write the DH table. Now that we've got both the parts, so the DH table looks like this. Link I1 to AI DI, sorry, AI alpha I DI theta I L1 L2 0 0 0 0 and theta 1 theta 2. Okay, that's step 2. Step 3 is writing the H matrix. H is a transformation from H1 to H0. There's a formula which I showed earlier. I would recommend putting this in MATLAB and just generating the 4x4 matrix. I'm going to write a shorthand form for this, and I'll put what C1 and S1 is. L1 C1 L1 S1 0 1, where C1 is simply cosine theta 1 and S1 is sine of theta 1. This makes me slightly easier to write this angle. H21 is going to be C2 S2 0 0 minus S2 C2 0 0 0 0 1 0, then L2 C2 L2 S2 0 1. So it looks very similar to the first one because it has the same DH values. Okay, so once we got these H matrices, we can get H2 with respect to 0 is H1 with respect to 0 times H2 with respect to 1. And so all you need to do is multiply those two matrices together to get something which looks like this. C12 S12 0 0. Again, I'm using a shorthand notation, which I'll just put down in a bit. 0 1 0, and then we have L1 C1 plus L2 C12 L1 S1 plus L2 S12 and 0 and 1. So here C12 is cosine theta 1 plus theta 2 and S12 is sine of theta 1 plus theta 2. So the question was find the position of the end effector, right? The position is simply the last column of this matrix. So the position is X end effector or let me do it this way, XYZ end effector is simply L1 C1 plus L2 C12 L1 S1 plus L2 S12 and 0. So that's basically, if you can check back with the formula I wrote down for planar case, that's exactly the formula you get if you use the transformations we talked about in the earlier classes. You can also do this with trig, and the orientation of the end effector is simply the 3x3 elements which make up the first three rows and first three columns of this matrix S12, C12, 0. In other words, it just says that the orientation is at an angle of theta 1 plus theta 2 along C axis, right? Sorry, Z2 axis. That's because C12 is cosine theta 1 plus theta 2. So this is like the complete setup going from scratch to deriving the DH parameters to getting the position and orientation. Okay. And if you are given, the hardest part was actually getting the DH table. Once you know the DH table, the rest of the part is pretty much algorithmic. It's very easy.